Hey folks, your favorite thing in the whole world, stoichiometry. Now we're talking about energy stoichiometry. It's always stoic. We do stoic all year. All right. Nitrogen reacts with hydrogen according to the following equation. We're starting with 13 grams of nitrogen. So we always start with the information that we're given, which is 13.0 grams of nitrogen. And what we have to do is get rid of grams of nitrogen. And we have to go to moles of nitrogen. Isn't that what we always do, is go to moles? Isn't that interesting? Now, when we are figuring out grams of nitrogen, it's N2. So that's 14.007 times 2, which is 28.014 grams in 1 mole. Now what we have to do is we have to go from moles of nitrogen to moles of energy, which is what it's asking. And over here you'll notice we have 1 mole of nitrogen. So we have 1 mole of nitrogen goes to 92.38 kilojoules of energy. And that's going to give us, well, let's see, we have 3 sig figs in our problem, so we're going to have 3 sig figs in our answer, which is 42.9 kilojoules of energy. Now, this next one's a little bit trickier. We have to be careful with this one. We have 2.5 liters of hydrogen, and it's reacting at standard temperature and pressure. All right, so we have to get rid of liters of hydrogen. We have to go to moles of hydrogen. Now, using the same logic we just did above here, we have to get rid of moles of hydrogen and go to moles of energy. But notice here we have 3 moles of hydrogen, and that's critical, because when we go from moles of hydrogen to kilojoules of energy, we obviously are creating 92.38 kilojoules, but we're going from 3 moles of H2. We need to make sure we write down the fact that this is 3 moles of H2. That's our relationship. And we know that 22.4 liters is in 1 mole. All right, so when we do the math here, we get to 2 sig figs, we get 3.4 kilojoules of energy. Okay, number 2. How much energy will be required when we start out with 32.4 grams of carbon disulfide, CS2? Well, I have to figure out how much CS2 weighs. Well, carbon's 12.011 and sulfur is 32.06, and there are 2 of them, so that's 32, that's 64.12. We add those together and we get 76.131. All right, and that is grams of CS2 in how much? 1 mole of CS2. CS2. But I don't want that, I want energy, so I have to convert from moles of CS2 to kilojoules of energy. Well, kilojoules is 23.5 kilojoules, and how many moles of CS2 am I starting with? Am I ending with? Right there. We look at that, and there's a 1 implied there, so that's 1 mole of CS2. This will give me exactly, let's see, I have 3 sig figs in my problem, so it's going to give me 10.0 kilojoules of energy. All right, how much energy will be required to react with 21.1 liters of sulfur? Liters. 21.1 liters of sulfur dioxide. And let's see, I have to convert from liters of sulfur dioxide to moles of sulfur dioxide. And that's always 22.4 liters in 1 mole because it says I'm at STP. And when I have moles of sulfur dioxide, I have to go from a relationship of 2 moles of sulfur dioxide to my energy. So 2 moles of sulfur dioxide. I'm going to my energy, which is 23.5 kilojoules. When I do the math there, I come out with 11.1 kilojoules of energy. 3 sig figs in my problem, 3 sig figs in my answer. Okay, let's keep going. Silver nitrate reacts with calcium. Notice I do not have a balanced chemical equation. So that's the first thing I have to do. Silver nitrate, it's AgNO3 plus calcium makes calcium nitrate, CaNO3 plus silver. All right, that's step 1. Step 2 is to balance my charges. Well, silver's +1, nitrate's -1. But when I produce calcium nitrate, calcium is +2 and nitrate's -1, so I have to crisscross them. So I have to have calcium nitrate with a 2 there. All right, well now I've balanced my formulas, but I have to balance my elements to make sure I have the same amount on each side. I got 2 NO3s on the right. I have to have 2 on the left, which gives me 2 silvers, so I have to have 2 silvers on the right. The reaction is exothermic, so it produces 18.7 kilojoules of energy, so the 18.7 kilojoules of energy goes over here. All right, so how much energy will be produced if I have 12.3 grams of silver nitrate? 12.3 grams of silver nitrate. And I have to get rid of grams of silver nitrate. And I have to go to moles of silver nitrate. And then I have to get rid of moles of silver nitrate and go to kilojoules of energy. I'm going to have 3 sig figs in my answer here. My kilojoules is easy. That's 18.7 in how many moles? Oops, 2 moles of silver nitrate. So 2 moles of silver nitrate produce that much energy. And 1 mole of silver nitrate, well, I have to figure out how much this whole thing weighs. Silver weighs 107, nitrogen 14, 3 oxygens weigh 48. Add them up and you get 169.877 grams. If I multiply that whole thing out, I get 0.677 kilojoules of energy. All right. This is interesting. This one works backwards. So we're starting with kilojoules of energy, 13.7 kilojoules of energy. So we have to get rid of kilojoules of energy, so we're going to work backwards. So we have to get rid of kilojoules, and what do we go to? Well, we're trying to get to grams of silver nitrate, so we have to go to moles of silver nitrate first, moles of silver nitrate, and then we have to get rid of moles of silver nitrate and go to grams of silver nitrate. And let's see, our kilojoules is 18.7. And our moles of silver nitrate is, again, it's going to be 2 because I've got a 2 up there. Right? And our moles of silver, how much does silver nitrate weigh? Well, we've already figured that out. That's 169.877, so we don't have to go through that math again. And we figured out that this is 249 grams of silver nitrate. That's a bunch of silver nitrate. Okay, that's your answer for that one. All right. Magnesium reacts with hydrochloric acid in a single replacement reaction. Notice again, I do not have a formula here. So magnesium reacts with hydrochloric acid. Okay, I just did silver nitrate, and that gives me hydrogen gas plus MgCl2. Magnesium is +2, chlorine's -1. So it's MgCl2. That means I need to have 2 hydrochloric acids, and that's 2 H's and 2 Cl's. I'm good, I'm balanced. Okay, let's see. The value is -221. What does that mean? When we see the negative sign, that means it's exothermic. That means we are producing energy. So my 221 kilojoules goes over here. All right. How many grams of magnesium will be consumed if we produce 365 kilojoules of energy? So I have to get rid of kilojoules and go to moles, and I'm going to moles of magnesium because that's what it's asking me about. And then I go from moles of magnesium, I go to grams of magnesium because that's what it's asking me for, is grams of magnesium. My kilojoules is 365. My moles of magnesium is 1. And so 1 mole of magnesium, if I go and look that up on the periodic table, that's 24.30 grams. Oh, that's interesting. Sorry, this is wrong. That's 221 kilojoules. Look at that number. That doesn't make sense. 221 kilojoules in 1 mole of magnesium. Right. I multiply this out, and I get 40.1 grams of magnesium. 3 sig figs, 3 sig figs. Okay, I also have 3 sig figs down here. So, how much energy will be released if I have 9.45 grams of magnesium? So now I'm working the other way. So I have to get rid of grams of magnesium and go to moles of magnesium. And from moles of magnesium, I want to get to kilojoules. Well, 1 mole of magnesium, we've already figured out that weighs 24.3 grams. And kilojoules is 221. And we're at 1 mole of magnesium. So if we divide and multiply this out, we get 84.9 kilojoules of energy. Okay, let's do the last one. We have ammonium sulfate reacting with barium hydroxide endothermically, because notice that our kilojoules is positive. So this says ammonium sulfate, which is NH4, SO4, reacts with barium hydroxide, BaOH, and I have to put in energy of 127 kilojoules, and that is going to produce barium sulfate, and it's going to produce ammonium hydroxide. All right, well, now I have to balance my charges. That's the first thing I have to do. Well, ammonium is +1 and sulfate's -2, so I need 2 ammoniums. And barium's +2 and hydroxide's -1, so I need 2 hydroxides. Barium's +2, sulfate's -2, so that balances. And ammonium is +1, hydroxide's -1, so that balances. Now I have to look and get the same number of things on both sides. There are 2 ammoniums on the left. I have to put 2 ammoniums on the right. There's 1 sulfate on both sides. There's 1 barium on both sides. And now there are 2 hydroxides on both sides. So I'm now balanced. Okay. How much energy will be required to react completely with that much barium hydroxide? So I start with 34.5 grams of barium hydroxide. And that means I have to get rid of grams of barium hydroxide. And I have to go to moles of barium hydroxide. Okay, and then I have to get rid of moles of barium hydroxide, and I want to go to energy. So I have to go to kilojoules of energy. So let's actually go through this. Grams of barium hydroxide. I have to figure out how much barium hydroxide weighs. Barium weighs a bunch, and then I have to multiply this part by 2. I've already done the math for you, and that's going to be 171.346. Good, Skip. Goes in the other place. 171.346 grams in 1 mole. And then I have to get rid of moles of barium hydroxide. Well, my moles of barium hydroxide, there's a 1 there, and it is consuming 127 kilojoules of energy. So if I do the math here, I get 25.6 kilojoules of energy. All right, and it says if 395 kilojoules of energy, how many grams of precipitate will be formed? Well, which one of these is a precipitate? Well, now I have to go out to my solubility table. And if I go to my solubility table, I figure out that barium sulfate is my precipitate. All right, that's going to be a solid, and the ammonium hydroxide is going to be aqueous. So it's asking me for barium sulfate. So I start with 395 kilojoules of energy. Yes, this stuff does build, folks. And I have to go from kilojoules of energy to moles of barium sulfate. Barium sulfate. And if I go from barium sulfate, I now have to go from moles of barium sulfate to grams of barium sulfate. Right. And I have to add these things up. Well, let's see. 1 mole of barium sulfate. Barium sulfate has a 1 implied in front of it. 1 mole of barium sulfate is how many kilojoules of energy? Well, it's 127 kilojoules of energy. But 1 mole of barium sulfate, how much does it weigh? Well, sulfate weighs 96. Barium, I've got to go out and look it up on the periodic table. That's 233.39 grams. If I do all the math here, I come out with 726 grams of barium sulfate. It's a lot of mass. All right, that's it. If you have questions, please see us in class. We'll be happy to help you. Take care.